All right, tonight what we're going to be doing is we're going to be doing another problem. In this case, once again, you're going to have to ask yourself, do I ever go to 0 or 100 during this temperature change? And for this one, you go from -7 and you go all the way up through 22. So yes, you do go through 0 at that point. Not 100 though. So what I'm going to do is I'm going to draw a heating curve. And that heating curve is going from -7 upwards. At 0, what's going to happen is it's going to level off, and then it's going to start increasing its temperature again. Looking at this, I know that this would be 22 degrees. I know that this phase change occurred at 0, and I know that we started at -7, so that would be down there. Okay? So now each time I am going upwards in my graph, I know that I'm going to use the MCAT formula, and each time that I am going flatlining, I know that it's going to be an HM formula. The first one that I want to deal with is the heating up from -7 to 0 though. Okay, so I know that the heating up from 0, or sorry, I wrote that wrong, from -7 to 0, okay, and then I know there's going to be another one, but right now that's what I'm going to focus on. So, knowing that it's going up in temperature, I know that I'm going to need to use my MCAT. I'm going to re-look at my formula. I know that my mass is 235. I know that my final temperature is 22, and then I started at -7. So I'm ready to plug into my formula. Once again, we are always only solving for Q in all of these problems, which is nice. So I know Q equals my mass, and my mass in this problem is 235. My C, this is one of the few situations, or the first situations, where you will be finding a C value that is not the 4.18. You are dealing with solid water, and if you look on your front of your sheet, you will notice that the C, or the specific heat for solid water, is different than that for liquid water. And this value in this case is 2.11. All right, and so then you're going to multiply by delta T, and you're going to take final, which is 0, minus my initial, which is -7. And so I am going to condense this and make it equal to 235 times 2.11. 0 minus -7 is going to be adding 7, so times 7. And when I multiply this out, I get 3,470.95 joules. All right, so this deals with this particular part. Now I'm going to deal with the HM of this part, which is the phase change. So this would be when it is considered melting. Okay, and melting is undergoing a phase change, so that would be the formula Q equals HM. So when we use Q equals, my H value for melting is going to be that of fusion, so that would be 334, and I'm going to times by my M, which is 235 grams. So when you multiply that out, you get 78,490 joules. Okay. And now I'm going to deal with the transfer of energy, or the change in energy, from 0 to 22 degrees. So that would be the change of temperature from 0 to 22. Okay, so whenever you once again change your temperature, you're going to do Q equals MCAT. So Q equals, once again my mass has not changed, it's 235. My C in this case for liquid water is that 4.18, because I know that it's going to be liquid water from any temperature between 0 and 100. And then my delta T is going to be final minus initial, so 22 minus 0, so that would be 22. So I'm going to put in 22 here. And now I'm going to solve it, and I get 21,610.6, right? Once again, the total energy is everything from point A to point B, which is the -7 to 22. So I'm going to add up all of these. So I add up 3,470 plus 78,490 plus 21,610.6. And you should actually keep all of those decimals. I'm just running out of space, so I'm not going to. And when you solve all of this and add it up, you get 103 571.6. Whoops. 571.6. Okay? And rounded to the correct number of sig figs. If you look at your problem, every single thing has 3 sig figs, so that would be 1, 2, 3. So that would be 104,000. So that would round up to 104,000 joules, which once again, moving over that decimal 3 places, 1, 2, 3, that's where you get that 104 kilojoules.